Every other animal on Earth eats its food raw. Humans are the only species that cooks, and that single habit may be the reason you're smart enough to be watching this video right now. This is called the cooking hypothesis, and it comes from primatologist Richard Wrangham, who spent decades studying why humans have such strange bodies compared to every other ape. Let's start with the problem. Raw food is brutal to process. Chimpanzees spend nearly half of every day chewing, 6 hours every single day, just chewing raw plants, fruit, and occasionally meat, because raw food is tough, fibrous, and calorie poor. Their jaws are massive, their guts are enormous, their teeth are built like industrial grinding machines, because that's what survival on raw food demands. Humans don't have any of that. Our jaws are small, our teeth are delicate compared to other primates, our guts are shockingly small for a great ape, about 60% the size you'd expect for an animal our size. And yet we have brains that consume roughly 20% of our total energy, despite making up only 2% of our body weight. This creates an evolutionary puzzle. A massive energy-hungry brain, a tiny weak digestive system, small jaws that couldn't possibly process enough raw food to fuel that brain. Something doesn't add up. Wrangham's answer: cooking. Around 1.8 million years ago, the fossil record shows a dramatic shift. Homo erectus appears with a smaller gut, smaller teeth, and a significantly larger brain than its predecessors. Something changed the entire economic equation of being human, and Wrangham argues that something was fire. Here's why cooking changes everything. When you heat food, you break down cell walls, denature proteins, and gelatinize starches before they ever enter your body. Essentially, cooking outsources a huge portion of digestion to the fire itself. Your stomach doesn't have to do nearly as much work, because the hard work already happened in the pot. Researchers have measured this directly. Cooked meat yields roughly 30% more usable calories than the same raw meat. Cooked starches can yield even more, sometimes double the digestible energy of their raw counterparts. Your body absorbs dramatically more energy from the exact same food just because it was heated first. This is the key insight. Cooking isn't just about taste or safety. It's a caloric upgrade. Every meal became more valuable the moment fire entered the picture. And this connects directly to what's called the expensive tissue hypothesis, developed by researchers Leslie Aiello and Peter Wheeler. Their argument is elegant. Brains are metabolically expensive. Gram for gram, your brain burns roughly 16 times more energy than your muscle tissue, but your body has a limited energy budget. You can't just grow an enormous brain without cutting energy from somewhere else. Aiello and Wheeler found that across primates, species with bigger brains almost always have smaller guts, and species with smaller brains have bigger guts. It's a trade-off. Digestion is expensive too, especially digesting raw, fibrous food. If you can shrink your digestive investment, you free up energy that can be redirected toward brain growth. Cooking made that trade-off possible. Once food was pre-processed by fire, our ancestors didn't need a massive gut anymore. That freed up energy budget could be spent building bigger, more complex brains instead. This is why human evolution and fire seem to move together in the fossil and archaeological record. As controlled use of fire became more consistent, brain size and ancestors climbed steadily, while jaw size, tooth size, and gut size all shrunk in parallel. But cooking didn't just change our biology, it restructured our entire social world. Think about what raw foraging actually requires. If you're a chimpanzee, you eat almost constantly throughout the day because raw food gives you so little energy per bite. There's no real concept of a meal. You're grazing nearly non-stop wherever the food happens to be. Cooking changed the entire rhythm of daily life, because cooked food is calorie dense and requires far less chewing. Our ancestors suddenly had free time. Anthropologists estimate that switching from raw to cooked food could have freed up several hours per day that would otherwise be spent chewing. What do you do with several extra hours a day? You don't just sit there. You talk, you teach, you plan, you build relationships. Wrangham argues that cooking fires became the first real gathering points in human history, the ancestral version of the dinner table. And a fire creates something raw foraging never could: a fixed location. You can't carry fire everywhere efficiently, and you don't want to abandon a fire once it's burning. So groups had to return to the same spot at the same time every evening to cook and eat together. This is a radical shift. For the first time, there were